Today we're going to talk about sanding to improve your bottom line and basically put more money in your pocket. So, removing costs from the sanding process. Some things we want to start off with here is some things to keep in mind. So, proper tooling for the application. Can your machine do all the work? There's many different tools we can put inside of a sander depending on what application that you would like to do with the machine. And you're going to see that later through this presentation. We're going to talk about reduction of labor. Is my sanding process efficient? How can it become more efficient? How much time are you spending changing belts on your current machine? Can you get everything done in one pass? Abrasive costs. Is my abrasive use efficient and cost effective? We're going to talk about some of the different types of abrasives and when to use some over others for different applications. Product consistency. Are your finished surfaces consistent from day to day? Are you having to spend time in rework from people hand sanding certain components too much? We're going to talk about how to eliminate or reduce that today. Work environment. Is your sanding process clean and safe? Let's face it, I don't know anyone that says, hey, I can't wait to go sand work pieces all day for 8 hours straight. We're going to talk about how you can reduce that or eliminate some of that hand sanding. So we'll start off. Why do we sand? Could be calibration sanding. Could be brush or orbital sanding to break those edges after we calibrate sand or remove those cross-grain scratch with our orbital sanding. It could be prepping veneer to go to finish for like architectural panels. Could be seal sanding in between coats and our finishing process. We're also going to talk about planetary sanding, miscellaneous sanding, and effect sanding. So let's get started. Again, why do we sand? Well, the first application is calibrate. Basically, when we calibrate, we're wanting to dimension a workpiece to a desired thickness. A common application of this would be to calibrate a cabinet door to a desired thickness of typically 3/4 of an inch. It could be to flatten a surface, such as a panel that's going to go later downstream and be in the pressing process to press a veneer on that panel. And we want to calibrate that thickness. Could be edge breaking. After we calibrate that door, we want to break those sharp edges so that stain will bond in those corners. It could be to create a desired scratch pattern. For the cabinet door, we put in cross-grain scratch on those rails, and we're going to need to remove that. It could be to clean up a panel surface. That could be from many different things. It could be from handling marks upstream on our veneered panels, just the grit that can get in between those panels and scratch it, or machine marks. It could be to reduce fiber rays. As you see in the diagram on the lower right-hand side, this fiber right here tends to pop up in between coats in our finish process, and we want to clip those fibers down and scratch that coating for a better bond in between coats. It could be to remove oils or other contaminants, as you see in this diagram on the top, and we want to open those pores up so we get a good stain penetration in our workpiece. And ultimately, our goal here is to prepare everything for the finish process. Our finishing process is only as good as a sanding that's done on the workpieces. So any of those blemishes created in the sanding process is going to show up during finishing. We're going to talk about polishing in between coats of high gloss. So let's start first with calibration sanding. What does that mean? What's our goals with calibration sanding? Basically, again, we want to dimension or calibrate that workpiece to a specific thickness. Typical tolerances is plus or minus 0.4 of an inch over 53 inches in width. And again, we just want to flatten those surfaces. If we don't do that, we're going to spend a lot of time downstream hand sanding to try to get out some of those high spots, and it's going to increase our labor costs. And ultimately, we're preparing that surface for finishing later downstream. That could be a solid wood panel that's going to be used for a furniture component. For our cabinet doors, again, it could be preparing it for orbital sanding later downstream. So let's talk about common configuration of a calibration machine. As you see in this diagram, this is a typical 4-head calibration machine. The first 3 heads are drums, our last head's a pad. We want to talk about skipping grits. We see it commonly out in the workplace, the operators skipping multiple grits, and we're going to go through that, why that's not a good practice. And as you can see in this diagram, it's okay to skip a grit from a drum to a drum, but you never want to skip a grit from a drum to a pad. We're going to talk about why you don't want to do that in the next slide. So the reason you can skip a grit from a drum to a drum is you can see we have a very small contact area on the tangent point of that drum making contact on our workpiece. So when you skip a grit from a drum to a drum, the second drum can get those deeper scratches out. However, if you skip a grit from a drum to a pad, as you can see, we have a large surface area with this pad. We can never get out some of those deep scratches by skipping a grit from a drum to a pad. So that's why you never want to do that. Also, you never want to skip a grit from a pad to a pad as well, too. You're going to hear the term grit compensation. What grit compensation means is, basically, as you see in this diagram, you may have some sandpaper that's thicker than other sandpapers, and you want to compensate the reference point of that head. An application of this would be a cloth belt that would be thicker on the right-hand diagram versus a paper belt that tends to be much more thin. So when you hear the word grit compensation, all we're talking about is changing that reference point of that drum inside of the machine due to the paper thickness. So this is a diagram of grit sequence examples. On the top diagram, it shows the proper grit sequencing. So you can see we start off with the 80 grit. That's basically our tool inside of the sander. So the lower that number is, the larger that tool is, and the more aggressive I can get with removing more stock. So as you can see in this case, we're starting off with the 80 grit. We're skipping 100 grit. Grit number 2 is 120. Then after 120 grit, we're coming in with the 150. And then our final grit is 180, giving us that soft, fine scratch. So that's a proper grit sequence. As you can see on the bottom diagram, we're starting off with 80. We skipped 100. We skipped 120. We're going to try to get out those deeper scratches with the 150 and 180. And as you can see, you basically get a hybrid scratch pattern. And with the human eye, this can be very difficult to pick up. This looks like a very smooth 180 scratch. However, when you apply finish to that workpiece, you see some of these deeper random scratches that appear out of nowhere. And what happens is those deeper scratches were never removed with that 150 and 180 grit paper. So that's why it's good, or it's actually critical practice to not skip more than 1 grit. This is an example of a 4-head machine that you're going to see later in a video. Our first head's a drum with 100 grit paper. We skipped 120 grit. Head number 2 is 150 grit. Head number 3 is 180 grit. Head number 4 is a chevron belt with 220 grit. So what is a chevron belt? The diagram on the right-hand side of your page illustrates what a chevron belt is. So this belt is basically, you can think of this as made up of felt strips. And these strips are applying pressure on, and in between the strip is pressure off. So what does that do for you? Basically, that creates a very short, shallow scratch. And as you can see in this diagram, that felt strip is in between your sandpaper and your pad that's applying pressure. So that short, shallow scratch helps hide oscillation lines. As you can see in the diagram on the left-hand side, our pad is a very small, soft scratch because, again, it's over a large surface area. So one of the challenges of that is our belt oscillation inside of the machine to track that belt. When we sand the workpiece without a chevron belt while using a pad, You may not notice these oscillation lines again until you go to the finish process, but at that time it's too late. So we can eliminate this with the Chevron belt and break up those scratches, giving you the highest quality scratch pattern available out of a wide belt sander, as you see in the diagram in the middle. So in this movie, this is on the HOMAG 345 RRRH, which means a drum pad. And as you can see, we're using a power touch control, and that's shared through a lot of the HOMAG family group of machines, such as CNC, edge banders, panel dividing saws, and in this case, the sander, as well as molders. So this is a very user interface. It says all the information such as feed speed, the different grits on those heads. It gives you a diagram of each tool. If we click on that individual tool, it can tell the operator, hey, make sure you have 150 grit paper in this case, 180, and 220, and it illustrates that tool with the Chevron belt. So let's take a look inside of the machine. Our first head is a steel drum. And as you can see in this picture, there's no belt on this. It's a helical steel drum. And the reason it's a helical steel drum is because now with steel, it's much more aggressive. It gives me a much more accurate calibration. The helical portion inside the drum helps the dust evacuate, and it also helps cool that head. This is a pneumatic cylinder that tensions the belt inside of the machine. So on our second head, this is the 85 Shore rubber drum. Our first steel head is the workhorse inside of the machine. Head number 1's doing about 70% of the stock removal. We also have our grit compensation. Again, depending on which grit or a paper belt versus a cloth belt, we can set that thickness. Head number 3 is a 55 Shore rubber drum. And the purpose of the rubber drums is, again, just to get out those deeper scratches and give us a more soft scratch with the appropriate grit. We also have automatic head locking on the machine, so you can see that there's no human interaction to lock those heads in place. Here you see the Chevron belt with the felt strips that's giving us that very soft, shallow scratch. This also makes it much easier to remove the cross-grain scratch after the calibration sand has been completed. And in the back of the machine, we have an air jet blow-off unit. So basically, that's just cleaning the part as it exits the sander. So now let's take a look and watch. We're going to calibrate sand this maple cabinet door. So we're going to measure our thickness. We're going to set our desired thickness in this case. The Power Touch also allows the operator to save any different recipes. So if you have an extremely hard cabinet door like a maple or a hickory door, you may want to run that slightly slower than, say, some softer materials such as cherry or a paint grade poplar door. And it allows that operator very quickly to select those different recipes to get the most out of that sander. So now that workpiece has been calibrated. As you can see, all the joints have been equalized, and we've taken that cabinet door down to a specific thickness. So the next step, once we calibrate that door, now we need to break those edges, and we would like to remove that cross-grain scratch in those rails. So what does that cross-grain scratch look like? You can see in this diagram on the top, this is our cross-grain scratch put into the cabinet door from the calibration process. So as you can see on the bottom diagram, that's been removed, which is going to be a much higher quality product. And we also want to break those sharp, crisp edges again, so our stain can bond to the corners of that workpiece. So how can that process be done to remove that cross-grain scratch? Well, as you can see here, you can have a person with a hand orbital, but we have to be very careful. You can see if this operator engages this hand orbital sander, they're going to automatically create a defect, a dip, deep scratches in that workpiece. They couldn't sand through that veneer or create swirl marks. So that you have to have a very trained operator for this manual process. Also, for our sandpaper, if they don't change that paper enough, they can polish that surface. Or if they change it too quickly, then they're just throwing away paper before getting the most use out of that paper. The abrasives cost for these small handheld orbitals is very expensive as compared to a wide belt sander. Another challenge here is if you've got 4 people breaking the edges of these cabinet doors in your manufacturing process, and one person is too aggressive on those corners, maybe you don't really notice because you're talking about 10 or 15 thousandths difference of more round over. Then it goes to finishing, then it goes to the homeowner, and they want to know why 1 out of 4 or 5 doors has an inconsistent surface finish versus the rest. So we can talk about how to eliminate that. This is the Heisman brush orbital sander. And as you can see, the benefits, we can break the edges with this machine. We can create an unpolished surface. We can remove the cross-grain scratches that our calibration machine put in those cabinet doors. We also have the ability to color match. I can reduce or totally eliminate hand sanding with this type of machine. It's extremely consistent and repeatable, and the surface is prepared for finishing. You can come straight out of this machine and go straight into your finishing process. So let's take a look at the Heisman in a little bit more detail here. So head number 1 is our RUT disc brush, and we typically use 180 or 220 grit paper on that head. Head number 2 is our barrel brush. We typically use 180 or 220 grit paper on that head. Head number 3 is our first orbital. This machine is going to do the bulk of the cross-grain scratch removal, and we typically use 180 grit paper on that head. Our 4th head is going to give us our final finish, and we typically use 220 grit on that head. So to dive a little bit deeper in what each one of these units performs inside of the machine, we'll take a look at the RUT disc brush. The purpose of this head is to break all those sharp corners. And again, I have control of the speed that brush is rotating. The faster, the more aggressive the edge break. Slower, the less aggressive. The bottom head is our drum brush. The purpose of the drum brush is to remove any swirl marks that the RUT head may have left. And it also gets down into those recessed panels, and it gives us a good sanded finish in that as well too. You can see that both of these heads use flex trim brushes. So you've got a huge amount of flexibility of what types of brushes you put in there as far as length, the stiffness of the brush, and what grit brush you put in there. So depending on what you would like to accomplish, you have a lot of flexibility with this type of head. So let's talk about the orbital heads. Our first orbital head's on a 10 millimeter orbit. Again, it's doing the bulk of the cross-grain scratch removal. Our second head's on a 5 millimeter orbit. And then you see the chevron belts in the diagram. The purpose of the chevron belt is to break up those orbital motions into quarter arcs. What this does for you, it gives you a totally random scratch. It almost looks like a very matted finish. So it will accept that stain evenly and remove all those cross-grain scratches. Another advantage of this type machine is it uses standard size belts, 52 by 103 inch paper-backed abrasive belts. This is one of the most economical belts on the marketplace. And again, you have such a large surface area. That's how we can get 10,000 plus cabinet doors through one of these type machines without even changing the belts. That's pretty amazing. And you don't spend all the time changing out the small pads with that small surface area with this type machine. And again, we can use aluminum oxide, which would commonly be used on the first head, and silicon carbide on the second head. But you can use aluminum oxide on both heads, depending on how dark or light you would like that stain to bond with your workpiece. Another thing about the Heisman Orbital, Heisman patented this technology in 2002, which is important to mention because there's not been a single bearing that's ever been replaced out in the workplace. So with this technology, you're going to have more uptime, and it's a lower cost of ownership considering the paper that it requires and the uptime of not changing bearings inside of a machine like this. So in this video, this shows the RUT heads, which are spinning on the carousel. And again, the purpose of these heads is to edge break those sharp corners on, say, a cabinet door, or it could be other MDF workpieces for that matter, an MDF door. This is our barrel brush to get down inside of those recessed panels. And again, we can set those speeds of each one of those heads and save those recipes. So if you've got an application where you want more edge break, you can save that recipe and it's extremely consistent. This is our first orbital head, and this illustrates the chevron belt running through that head, breaking up that scratch. And then our fourth head is our other orbital. So now we calibrated this maple cabinet door, and we're going to break these edges and remove that cross grain scratch that we put inside of those rails. So as you can see, this is a very matted finish. The stain will bond. All the cross grain scratches have been removed at this point. So this cabinet door can be taken straight into your finish line and should be finished within 24 hours. And again, you can save those different recipes for more or less aggressive edge break. So now my colleague Aaron Brink, our product manager here at Stiles Machinery, is going to talk about some of these other applications, starting with veneer sanding.
Hi, everybody. Thank you, Addison, for getting us started here, and now I'll take us through some of the other processes. So we're going to start here. I'm going to start off by talking about veneer sanding. And veneer sanding is one of those topics that people either know really well or they don't know much about. But it's one of the topics that pretty much everybody does at one time or another. So I think it's an important topic. And it's one of the most common processes where we see a lot of labor being put into that process, because the most common way people are veneer sanding is with a hand orbital sander. And there's certainly ways that we can reduce that. One of the most common myths with veneer sanding is people saying or thinking that they are buying pre-sanded veneer, which is true in many cases, and that therefore they don't need to sand the veneer again because it's already been pre-sanded. Now, the reason why I say that's a myth is because there really is no such thing as pre-sanded veneer when you talk about why you're sanding. And again, we talked about we have to remember why we sand, and that's very important when we sand veneer, because really pre-sanded veneer only means that it was previously sanded. So when we talk about veneer thickness, if we talk about unsanded veneer, usually we're talking about something that has a thickness of about 20 thousandths or half a millimeter. And after it's sanded, or if it's been pre-sanded from the mill, usually it has, say, 60% of that veneer left, which means we don't have a lot of material to work with, but we still need to sand that. And when we go back to the why, we do that as the first step in our finishing process. So when we talk about the why, right, Addison mentioned that you should finish within 24 hours. And the reason is because we sand in order to prepare for finish. Here you can see the water drop test. And on this side, on the left side here, you can see something that was sanded and then left, say maybe for a few days, or it wasn't sanded at all, and a water drop was put on the surface. You can use like a little water drop medicine dropper that you can get at any drugstore, and you can do this test yourself. You'll see that on an unsanded surface or an old sanded surface where the pores of that wood fiber have closed up, the water wants to bead up and does not want to absorb very evenly. Whereas on the right-hand side, something that was freshly sanded, the water drop wants to dissipate very quickly. And this is an important thing to understand, and important to understand why we sand from this regard, because this helps in our finish process tremendously. I'm sure that nobody's ever had to fight with a blotchy finish or barber pole or anything like this in their finish process. And a lot of times the main culprit is either not sanding, or maybe they're sanding and they think, oh, well, I sanded this, why isn't it turning out right? But they may not be sanding it and then finishing it in a proper time frame in order to effectively be using the sanding for the job in which it was done. So again, a very important thing to remember, especially with veneer sanding, because you need to have that stain absorption, and it doesn't happen much without properly sanding it first. So when we talk about the veneer sanding, again, the goal is, one, to establish a final finish, or a finish that's going to give us the appearance that we like, and something that's going to prepare that surface for our next process, which would be painting or coating, or maybe it's polishing of some sort. The considerations in terms of the technology, of course, are first the type of sanding heads. Addison mentioned a little bit about drums and a chevron belt. But usually in the case of veneer sanding, we're going to be using pads, and specifically segmented pads, which I will talk about in just a moment. Sanding pressures are important to understand. Again, you actually do need to sand with a fair bit of pressure on, even though it's sensitive. Otherwise, you won't do a good job. Cutting speeds. Cutting speed would be the speed at which the abrasive belt is moving, and I'll explain that in a little more detail here in just a moment too. Feed speeds, that's how fast is the conveyor moving or the part moving through the machine. Abrasives, Addison mentioned a few things about both aluminum oxide and silicon carbide. Depending on how we use those abrasives or what abrasives we use are going to determine our finish. And of course, cutting direction. So when we talk about veneer sanding, again, some of the benefits to sanding with a machine in doing that process is, of course, we get a nice smooth finish, which is something that's required. We can reduce our fiber rays or fiber rise, the fibers that pop up. If we do it effectively, we can help downstream and remove costs downstream, which otherwise we all know that we get fibers that rise up after we put our sealer on. We get a consistent and repeatable product time after time, regardless of if it's morning or 4 in the afternoon, and regardless which operator is doing it. We reduce the hand sanding that's typically involved, obviously, to sand the veneer, but also we are able to therefore reduce sanding downstream, which would have to be done by hand if it's done in the veneer sanding step by hand. And of course, it's the first step in our finishing process, which means as that we want the opportunity to have some control over that process. So by automating this, it gives us the ability to audit that process and control that process so that we really are in control of our finish and what the quality that's coming out of our process is. So a little bit on the technology. The segmented pad technology has been around for a long time, but it's important to understand what it is. If you can see on the image on the left and my cursor, on any segmented pad system, you have a set of sensing rollers that are on the front of the machine. The sensing rollers basically locate the edges of the part. They track where the edges, inside edges, outside edges, leading and trailing edges, and they fire segments. And segments are basically inside the machine, inside the abrasive belt, pushing down on the abrasive belt in order to basically put pressure only on the workpiece where we want the pressure. So in a case like this, where I had a frame, I would only be firing segments that were on the area that I'm intending to sand so that I don't burn through sensitive surfaces. Segmented pads, of course, have float because each individual segment is separately controlled, and you can control the pressure. And depending on the system will determine how you control that pressure, but you can control the pressure and how hard you're pushing down on the surface. So of course, if I look at a workpiece as I'm feeding it through the machine, I can control for my leading edge, my trailing edge, and both my left and right pressures, and including even inside and outside pressures if there's cutouts on the inside. So it allows me to be very sensitive and very gentle on that workpiece, but still sand it without having to do something by hand. And the important thing to note is with this technology, you actually can do a much more effective job than hand sanding because you actually do sand all the surfaces the same instead of being a little lighter in certain areas because somebody's afraid they might burn through. Taking the segmented pad to the next level is what we call the magnetic segmented pad technology. And again, it's still a segmented pad. What a magnetic segmented pad can do, and I'll explain it here with this little diagram. A typical segmented pad basically operates on some sort of pneumatics or with a piston. And this is commonly called a pneumatic segmented pad, or oftentimes just an electronic segmented pad. And here, this diagram, you can see I have a sensing roller at the front of the machine that's sensing where the part is. And as it comes in, if that roller was activated, this segment will fire. And if any part of the workpiece was under that segment is going to fire. It's going to turn on or it's going to turn off. And of course, I can set some timing. So where's the front edge? Can I be less or more aggressive on the front and rear edge? But generally, it's on or off. When I have a magnetic segmented pad, the difference with that is I have multiple sensing rollers for one segment. And essentially, I can vary or dynamically control the pressure on that pad based on how much of my workpiece is under the pad. So you can see in the image here on the left, I have something that was kind of pointed. And as it obviously gets wider, where I have more surface area under one individual little pad like here, it will ramp that pressure in and out. And it does that by a coil, which gets a charge. So basically the coil takes an electrical charge and that electricity creates an electromagnet. And depending on how much charge I give it will determine how much force it has. So I'm able to be very, very sensitive. Each pulse from my encoder tells me, was there something under 1, 2, 3, 4, however many sensing rollers at that moment in time. And I create a very high resolution, basically image of what I'm sanding, so that I can be very, very sensitive. So just as a frame of reference, I'm about 100 times more sensitive with a magnetic segmented pad system than I would be with a pneumatic system by the way that it works. So again, important to understand the technology and what's possible. So some of the terminology here when we're talking about fine sanding, particularly important, one would be cutting direction. So cutting direction, obviously the most common way would be what you see in this picture, which would be against the feed. So if my part was moving this direction, my belt's gonna rotate in this way, which would be against the feed. I can also cut with the feed, which would be running in the same direction as my conveyor belt is running, or I can use cross belts to cut across the workpiece surface. So I can cut in multiple different directions. And especially when we sand veneer, this can be an important consideration because oftentimes the way veneers are laid up, you have multiple different pieces of veneer, leaves of veneer spliced together, and you don't want them to lay down, or the fibers to lay down differently. So if you cut multiple different directions, much like mowing your lawn, you cut those fibers very short and you're left with less fiber rays in your finished process. Cutting speed, another important variable. That's how fast is that belt moving. That's going to determine how much material am I removing, or how much fiber am I removing from that workpiece. Sanding pressure, how hard am I pushing down on the surface? And of course, feed speed, which is also sometimes called dwell time based on how much time is my abrasive belt in contact with my workpiece. So now we're going to look at a machine, a typical veneer sanding machine. And here you can see we have 3 belts, a cross belt, a wide belt, and a chevron belt. All 3 of these heads in the machine that we're looking at here have a magnetic segmented pad inside. Again, we can control feed speed, control thickness, and we have a lot of control with such a head. Every head has a frequency drive, which gives us control over the speed of that head. You see the second head here and the last head here. And go back again to the combi head here. We can activate a drum here, and that gives us a lot of flexibility in a machine like this to be able to do pretty much everything, whether it's veneer sanding, calibration, finish sanding, or anything in between. So here, looking inside the machine, you can see what the cross belt looks like. We have a chevron belt on that cross belt to help keep it running cool and get rid of the dust. You can see the grit compensation there on the combi, along with the helically grooved steel drum for some calibration capability. And again, the last head, we have a chevron belt, much similar to what Addison was showing, but in this case, we have a magnetic pad inside. Again, you can see the automatic head locking. Again, when the doors close, the heads automatically lock. Another convenient feature that we have on the Homag sanders in order to eliminate forgetting to do something. Now we're going to measure that workpiece, and you can see here we have a wireless caliper, Bluetooth. It's a nice feature that we have on the Homag sanders where we can measure a workpiece and send that right to the controller. One of the most common issues with sanding is often we're either trying to remove too much or too little material, and oftentimes that can happen based on the thickness. One nice thing about magnetic segmented pads is I do have plus or minus 1 millimeter of float in my pads. So even if my thickness isn't exactly right, I will still sand that workpiece exactly the same as I would if it was entered correctly. And of course, we all know that there's variation in panel products. And so obviously we want to be able to accommodate and float on the surface, even if we have some variation in one batch of boards to the other. So again, we measure that. He hits the send button, and that's going to send the thickness to the controller automatically and set up the thickness without having to do anything more. You can see that happening here in the control. Once it's to the thickness, the conveyor turns on and is ready to go. And again, we'll go back to the home screen. You can see we're running all 3 heads in this case at a moderate feed speed of 8 meters per minute. Usually we run veneer around 8 to 10 meters. And again, he had pencil marked that all the way around very close to the edge so that you can see what's going to happen. We're sanding the surface skin with all 3 heads. It comes out and it's going to get blown off with a set of rotary air jet cleaners. And the workpiece, of course, comes out, and that would then be ready to go straight to the finishing department. So again, a very nice scratch pattern, sanded consistently from edge to edge, even down into the corners. Even if we have very complicated shapes, we can do that effectively with the magnetic pads. And we take out all the veneer sanding by hand out of that process. So again, very effective, very consistent, very controllable, and helps us reduce labor out of a veneer sanding process significantly. Moving on to seal sanding or primer sanding. So again, going back to the why would we sand sealer? If it's not apparent, of course, the real reason why is that we're preparing that for the next layer of coating. And when we look at what happens, right, if you see the image here on the right, when we coat a workpiece, seal it, what happens is we get fibers in the wood that rise up, and everybody realizes what happens there. You put something wet on something that has fiber, and they want to raise up like little whiskers. So when I put the sealer on, of course, it fills in my valleys, and it obviously kind of tries to cover up some of those fibers, but of course you get fibers that raise up. And in the seal sanding process, we need to obviously level everything out for one. And this would be the optimum range. We want to level or flatten that surface out. And we want to make it smooth, as smooth as possible, and give it some mechanical adhesion. So the mechanical adhesion gives us something to bite onto with our next layer of coating. So some of the considerations there when we're sealer sanding is, of course, our type of coating. Different types of coatings have different hardnesses, so we have to be able to sand those things differently, and that gets into a little more detail than we're going to talk about today, but an important thing to understand. The application process, right? We have to understand the steps. Where in the process are we doing what? Is it in a finish line? Is it offline? Sequence at which things are sanded. Understanding feed speeds. Typically when we're sealer sanding, we're sanding fast. We don't want a lot of dwell time. And our cutting speeds are always going to be slow. We need them to run slow because really we're just abrading that surface. We're knocking down some fibers, but we don't want to remove that thin layer of coating. Abrasives, we're typically using silicon carbide. And actually, believe it or not, we require quite a high motor torque because we run at such slow speeds, and we need pressure in order to do that. So again, going back to the technology, we already talked about the segmented pad technology, but we need segmented pads, much like we talked about in the veneer side. We want to float on that surface and have control over all our edges, and we need to have a variable cutting speed so we can run the belt speed very slow. The benefits, of course, when we seal sand with the machine are we create a uniform and smooth foundation for our next layer. We create mechanical adhesion by abrading that surface so that we get a good adhesion on our top coat or our next coat to create a good tough finish. We also can reduce the amount of top coat, and we could save money in our coatings area by reducing our top coat because we made that smooth and we didn't have to apply as much coating in order to get a proper smooth finish. We get obviously consistent and repeatable sanding job regardless of our workpiece geometry. And of course we reduce hand sanding, which saves us money on labor and also on abrasives. In the end, we get a better overall finish and we have some control over the process. So next, we're going to run here a piece of veneer that's been veneer sanded and then sealed. Again, we're measuring the workpiece, sending that to the controller. And in this case, we're actually only running the last head, the chevron belt, because we don't need to be so aggressive on that workpiece. And you can see we're running actually at 12 meters per minute, faster than we were running previously. But the belt is only running at 4 meters per second. So again, I'll put it in the machine. The chevron belt's gonna sand the workpiece, and then we're gonna blow off the workpiece so that it's clean. And it comes out of the machine, and basically it's ready to go straight back to get its top coat. Now you can see, it's hard to see, obviously, such a finish in a video, but you can see some little dots here and there. And what that is we're cutting down those fibers that have raised up, and we're just overall smoothing out the surface and creating some mechanical adhesion. So it does a phenomenal job to create a very, very good finish downstream without a lot of labor involved. Next, we'll move on to something that's a little bit more unique, or maybe not as known or understood, and that would be planetary sanding. So first, what is a planetary head? And you can see in the picture on the right what a Heisman DBS planetary style head looks like. The basic functions of a planetary head are you have 2 rotations. You have a gearbox or satellites, and you have disks or planets. That's why it's called a planetary system. Basically, you have a double overlapping rotation. You have disks that rotate and a satellite that rotates. And of course, you have interchangeable disks on a planetary head, which allows you quite a bit of application flexibility. So you can see in the image here that we have flexible strip abrasives for doing something like edge break or profile sanding. But we could also put tools like orbital discs or pads or even wire brushes in such a head to give us a lot of different application flexibility. Some of those applications, like I mentioned, could be breaking edges, seal sanding a profiled surface like a kitchen cabinet door, texturing, especially on things with multiple grain directions. Again, like a kitchen cabinet door, you could do that assembled. Solid surface finishing, again, maybe like with Scotch-Brite pads, trying to remove any linear scratches or defects. And you can even do some orbital sanding with hook and loop discs. So again, very, very application friendly. You can do a lot of different things with one head. So I will show a couple videos here now where we show a few of those examples. One of them is MDF preparation. And again, we'll run the video here. You can see in this video that we have an MDF door that was routed out on a CNC router. And obviously we've marked it up with pencil. It's going fairly slow to give us some dwell time to actually sand the surface there. You can see we're running just that planetary head. Now a drawer front, again, pencil marked in order to show that we're going to remove those pencil marks. Inside the machine here, you can see the planetary head running and how that looks when it's running. You have a double rotation there on the brushes. And that head, the overall head, can slide out in order to change the tools quickly and easily. So of course it puts into a park position and you can easily change those. Now the workpiece is coming here into the sanding head, and of course we're attacking all of the edges very, very consistently with that type of head, and that's one of the main benefits. You get a very consistent edge break, and we also sand on the surface. So that workpiece now has come out, and you can see that all the pencil marks which were marked on the stiles and rails and even in the panel have been removed. And again, the drawer front now is going to come out. You notice how small that drawer front is. Even with small parts, we can effectively brush sand those. Again, pencil marks removed. Next, we're going to actually sand some primer or sealer. In this case, it's a primed hardwood door. And in this case, you can see we actually have putty also on this door. One nice thing with a planetary head is we can also use belts in conjunction with that to do things that otherwise we wouldn't be able to do just with a brush. So we will flatten out that putty and also give a nice scuff sand across the whole surface, including in the profiles. Again, you can see the putty there. And in this case, like I mentioned, we're going to be running both the Chevron belt we have on this machine and the planetary head. So we're going at a fairly good clip again because we're sanding primer or sealer. The magnetic pads there are going to fire very sensitively so we don't burn through. And then we're going to give the final touch with the planetary head, including getting down in all the panels. And that workpiece is going to come out and it's going to be ready to go straight into finish to get the top coat on without having to touch that by hand. So again, taking a very dirty, messy process that's hard to do consistently and providing some automation in order to do that efficiently, a lot less labor and a lot less cost. Finally, some miscellaneous applications, one of those being texturing. Texturing is pretty common nowadays. The goal, of course, there is to create some sort of visually pleasing surface, oftentimes something that looks weathered or has grain removed. And of course, the benefits of doing this with a machine would be that we can create an aesthetically pleasing surface that's consistent, but it can be really time consuming to do by hand. It's something that a lot of people request, but oftentimes they don't want to do because of how time consuming it is. We can do texturing with discs, like I mentioned on the planetary head. Something like that can do a very good job on something like the 5-piece door that you see on the right-hand side. You can texture that assembled. But you can also use barrel brushes, which is the more typical way to texture. And of course, depending on the application, how deep you want to texture, what the workpiece is, what the species are, is going to determine which type of head you would use for your texturing. Another trend that's growing in popularity in the market is something called effect sanding. And again, the goal with effect sanding is to create different looks, right? one of those looks could be something like hit and miss, maybe like it came out of the mill. Maybe it would be bandsawn. We can do that with cross belts. You can see that look here in an image. Again, a piece of flooring, custom flooring. Maybe it's sanding through different layers of coatings to make something look like barnwood, or even in combination with texture so that you can see it looks like something old or vintage. The benefits here are you obviously create some sort of an aesthetically pleasing surface. Maybe it looks good to some and not to others, but that's irrelevant. You can do that consistently and repeatably, and you can produce it the same in the morning, in the afternoon, or in a month later when they want another piece to match. So again, very time consuming to do by hand, but something that you can charge a premium for if you can do it effectively and efficiently. So some closing thoughts here. Of course, the question always with sanding is what makes a good sanded finish. And you know, I've listed a couple things up here that sometimes these are the reasons, or these are what we gauge by, right? Is something the correct thickness? Is it flat versus being smooth? Are the defects removed? Did we remove cross grain, scratch? Did we remove fiber rays, or have we minimized the fiber rays? Did we get a true final scratch, what we really needed in order to get the proper finish? Is it ready for finishing, right? And all of these things, and of course I can't give you the answers to these, but the real goal here is you have to remember why you sand. If you remember why, and then go back and ask yourself what makes it good and why am I doing it, that will help you figure out how you can do it the most effective as possible and remove labor from the process. We're not here to let you figure that out by yourself. We have a whole team of people in order to help you with that. And you can see here a list of our product specialists, Addison being one. Feel free to reach out if you would like help, if you need help in your shop to figure out what a solution for one of your applications or challenges might be. We definitely would love to help with that. And that's what we do on a daily basis. So again, don't be shy on that. Lastly, one resource I want to point out, we're often asked, as it's obviously a very application specific type of product and job when we talk about sanding. And so it's always challenging, especially when you have operators that don't understand some of the basics on sanding. We offer several different classes, and we have actually a web-based class which is coming soon to our online platform called Sand 100. This will be about 3 to 4 hours of content that's somebody can work through at their own pace. That'll be a very nice tool that, again, if you have people that are new operators or people that are new to your company that you want to get familiar with sanding, something like that would be ideal to get them familiar. And then we also have another class which really takes a deep dive, much deeper than we talked about today, into sanding and more specifics, including theory in class as well as hands-on. And we do those classes both in our own facilities as well as at 3M. In their R&D center, we have a machine there, and we work closely with them. And if you've ever been to one of those, I think you would agree that they're phenomenal classes, especially if you get a chance to go to 3M. I would highly, highly recommend that. It's worth the price of admission just for the innovation tour that you get of their innovation center. So again, some resources there to think about. And with that, I think we are finished, and we can open that up to any questions that there may be.